All right, welcome to Geometry, Section 1-7, Midpoint and Distance. These are two formulas that are going to help us on the coordinate grid. So if you have 2 points and you draw a line between them, you're going to be able to find the length of that line, even if it's diagonal. And you'll also be able to find the midpoint of that line. So let's jump into it. By the end of this lesson, you should be able to find the length of a segment by using the distance formula. Find the midpoint of a segment by using the midpoint formula. Also, find the coordinates of an endpoint given one endpoint and the midpoint. So, let's start with the distance formula. This might look big, bad, and complicated, but once you understand what it's saying, it's really not that bad. I see a lot of X's and I see a lot of Y's because when you have a line on the coordinate grid, you've got 1 point here, you've got 1 point here. Each point has its own coordinates, so an X and a Y here, and an X and a Y here. So all this means is that the distance between 2 points is the square root of my X coordinate from 1 point minus the X coordinate from another point, and then I square that distance, or square that difference, and then add it to the Y coordinate from 1 point minus the Y coordinate from the other point, and then I square that. So that's what the distance formula looks like. Let's take a look on how we can use it in practice. So here we have segment AB, we can see right here on the grid, and it tells us that point A is 1, 5, and that point B is 7, 2. And we're going to use this distance formula in order to figure out the length of that segment. If that segment were perfectly vertical or perfectly horizontal, we could just count how many boxes it is. But because it's diagonal, we need to use the distance formula. So let's go ahead and do that. Actually, it's not x squared, it's x2. Actually, I say it x sub 2, sub meaning little, just meaning it's the x coordinate of my second point. So there's my formula. And since this is my first coordinate, let's say A is the first coordinate. It doesn't matter whether you choose A or B. So that means 1 is going to be my first X coordinate, and then 5 is going to be my first Y coordinate. And then down for point B, 7 is my second X coordinate, and 2 is my second Y coordinate. So now that you understand what x1 and y2 and all that stuff means, all you got to do is just plug those numbers into that formula. So distance equals the square root of x2 minus x1, so 7 minus 1 squared, and then y2 minus y1. So 2 minus 5 squared. So order of operations tells me that I need to do parentheses first. So inside the parentheses, 7 minus 1 is 6. And then 2 minus 5 is negative 3. And now that I've done parentheses, I do exponents. Now here's something that I see happen all the time, and people screw this up left and right. They take a look at this and they say, okay, well, negative 3 squared, that's going to be negative 9. No, it's not. Anytime you square something, you'll always get a positive quantity. So -3 times -3 is +9. So if you're doing the distance formula, and once you square both things, if you're subtracting after you've squared, you're doing it wrong. You should always have a plus sign in here. Neither one of these numbers should be negative. Okay? So I get the square root of 45, which if I plug that in my calculator, is going to be about 6.7. So that means the length of AB is about 6.7 of these blocks. Now, just to verify that we're right, notice how this program that I used already calculated the distance. So that's just proof that the distance formula works. Matter of fact, that's probably how this program determined that, was by using the distance formula. Let's do another example. All right, here we're going to do the exact same thing, or actually I could show you something a little bit different. The way that the distance formula was derived is based off of the quadratic formula. Sorry, not the quadratic formula, the Pythagorean theorem, which is a squared plus b squared equals c squared. And so what they did was they said, okay, if I've got this slanted line, I can make a right triangle out of that. So there's one side. There's another side. And I can, because those lines are vertical and horizontal, I can actually count how many boxes there are. So there's 3 of them there, and then 6, 7, 8, 9, 10. And so then I can do 3 squared plus 10 squared equals c squared. That's 9 plus 100. And then to get c all by itself, I just take the square root of both sides, and I get about 10.4. Although on the homework, if you left it as the square root of 109, I'd be perfectly fine with that. So if you don't like the distance formula and you'd rather use Pythagorean theorem, you're certainly welcome to do so. Not a problem in doing that. So now, just to kind of emphasize that the distance formula works, let's go ahead and use the distance formula. So distance equals square root of x2, so 4 minus -6 squared, and then y2 minus y1 squared, so -5 minus -2. So parentheses, I have to do 4 minus -6, and if you recall, minusing a negative is the same as adding a positive. Same thing over here. So 4 plus 6 is 10. -5 plus 2 is -3. And take a look at those numbers. 10 and 3, or -3. That's very similar to what we have over here with the Pythagorean theorem. So when I square both of those, I get 100. And -3, again, when you square that, you should not get a negative number. -3 times -3 is a +9. And honestly, I'm fine if you leave it as the square root of 109. Not a big deal. So you can see we get the exact same answer no matter which way we do it. Matter of fact, the way we get this 3 and this 10, basically I'm just figuring out, okay, what's the side-to-side distance from A to B? So the side-to-side distance is one of my x-coordinates minus my other x-coordinate. And then the way I got this 3, that's the difference between one of my y-coordinates and my other y-coordinate. So you can see how that fits nicely inside the distance formula. Now, you don't need to know that. I just thought maybe if I connect the pieces a little bit better, maybe this will stick up there. All right, let's move on to the next example. All right, next topic is the midpoint formula. So we're back to our first example where we had segment AB. And what we're going to do is, instead of finding the length of AB, we're going to find the midpoint. I think this is a lot easier than finding the distance. So let's take a look at this equation up here. x1 plus x2 divided by 2, comma, y1 plus y2 over 2. So basically, if you have your two endpoints and you want to find the middle, you just find the average. Average up your x-coordinates, average up your y-coordinates. So if I take a look at what we're doing over here, my x-coordinates are 1 and 7. So add 1 and 7 and divide by 2. My y-coordinates are 5 and 2. So add them up and divide by 2. My x-coordinates, 1 plus 7 is 8. 8 divided by 2 is 4. 5 plus 2 is 7. 7 divided by 2 is 3.5. So that's the coordinate of the midpoint. So if I go over 4 and up 3.5, that would be my midpoint. Looks right in the middle to me. So that's the midpoint formula. Just add up your x-coordinates, divide by 2, add up your y-coordinates, and divide by 2. You don't even need a graph to do this. If they just say find the midpoint, all you got to do is just add up your x's, divide by 2, add up your y's, and divide by 2. Now, if instead of putting 8 plus negative 2, if you just put 8 minus 2, that'd be fine. Either way, 8 plus negative 2 is 6. 6 divided by 2 is 3. 13 plus negative 3 is 10. 10 divided by 2 is 5. Much easier than the distance formula. All right, last topic. What if instead of giving you two endpoints and you finding the middle, what if they give you one of the endpoints, the middle, can you find that other missing point? So here they say one of the endpoints is 4, negative 1. The midpoint is 1, 6. And they want to know what that missing endpoint is. Let me show you how the book wants you to do it. They want you to say, well, if I take a look at the x-coordinates, the midpoint, the x-coordinate is 1. And so that's equal to one of my x-coordinates plus the other one divided by 2. And I can set the same thing up for the y-coordinate. So my y-coordinate is 6. So I take one of my y coordinates and my unknown y coordinate and divide that by 2. And then to solve for those, let's get rid of the fraction by multiplying by 2. So that 2 and the denominator cancel out. Subtract the 4, and I get negative 2. Do the same thing over here. Multiply both sides by 2. And then get rid of that negative 1 by adding 1 to both sides. So that means my coordinate is negative 2, 13. Man, that was a pain in the butt. Do you want an easier way to do it? I would love to show you. I don't want you doing that. There's something much easier that we can do. So let's get rid of this madness that we just did. All right, we're still going to end up with the same answer of negative 213, but let's find a much easier way to do this. So what I'm going to do is I'm going to stack up my coordinates. So here's endpoint 1, which is 4, negative 1. Here's my midpoint, 1, 6. And I'll put endpoint 2 right there. Now let's just think about this reasonably. If I take a look at my x-coordinates, I start off at 4, and then I get to 1. How do I go from 4 to 1? I subtract 3, don't I? So, to go from here to there, if I subtract 3, let's get from the midpoint to the other endpoint by subtracting 3 again. So 4 to 1, subtract 3. 1, subtract 3 is negative 2. Let's do the same thing for the y-coordinates. How do I go from negative 1 to a positive 6? I add 7. So let's add 7 again. 6 plus 7 is 13. So as you can see, I get the exact same answer, but a lot easier. Let's do another example. If a segment has one endpoint at negative 3, 5, and the midpoint is at negative 1, 4, find the other endpoint. All right, let's do it. So how do I get from negative 3 to negative? Let's do that one a little bit better. There we go. How do I go from negative 3 to negative 1? Well, I add 2. So if I add 2 again, that gives me a positive 1. And how do I go from 5 to 4? I subtract 1. So let's subtract another one, and I get 3. So that's my midpoint, 1, 3. If you like stacking it up a little bit, that would work no problem. So start at negative 3, 5, negative 1, 4. So going from negative 3 to negative 1, you add 2. So let's add 2 again and get 1. To go from 4 to 5, you subtract 1. Let's subtract 1 again and get positive 3. No matter how you visualize it, the process is much easier than what the book had us doing. Let's do one more. So one endpoint is at 2, 6. The other one is at 1, 6. So from 2 to 1, subtract 1, so that'll take us down to 0. And the y-coordinates, it's 6 and 6, well, nothing changed. So this one's not going to change either. And that's how you find the endpoint when you're given a midpoint and the other endpoint. If you guys have any questions, please feel free to email me. Feel free to ask me in class, even if we are on a hybrid model. And we'll get through this and get ready for the upcoming tests. All right, hope you guys have a great day.